Michael Kubba.
Well, thank you so much. Can everyone hear me? Can you hear me back there as well? Okay, awesome. Well, I am so excited to be here with you today. Professor Wang put out the bat call, and of course I came down. I want to talk about product design, product development. I've spent my whole professional career in product development, and I'm going to give you a little bit of a background into some of the products that I've worked on. I started my career in the aerospace industry working on heads-up displays for military planes at Rockwell Collins. Really long development cycles. I think I worked there for 2 years, and 4 years after I left, they still hadn't released a product, the product that I was working on. And that pace just didn't solve for me. So that led me to Apple. And at Apple, I led the design for the first Apple TV and the first aluminum remote, which was probably the coolest product, one of the coolest products I've ever worked on, as well as many other, different products there, and overlapped with Professor Wang. From there, I went to Tesla. I was employee 450 or something at Tesla, and led the design for the power electronics group. And the week that I started, we started working on Model S, and I left shortly after we launched Model S into production. We went IPO during that time, and it was an amazing time to see the trajectory of a company grow. I think when I left, it was maybe 5,000 or 7,000 people. From there, I went to Google, and I worked on a couple versions of Google Glass, which you may have seen in the news, glass holes, and a bunch of wearable products that actually never got released. And that's where Professor Wang and I worked very closely together at Google X. We also worked for Tony Fadell, and that was a very exciting experience. And then there were a couple other products there in Google X, like contact glucose monitoring and stuff like that, which were much further out, which were cool technologies. But I got tired of products getting canceled, and so I wanted to work also in a smaller environment. And so that kind of ended my time in the bigger companies. And for the past 8 years, I've been in startups. So the first startup was at Shaper Tools, which was a handheld CNC machine, or basically taking automated manufacturing and hand tools and bridging them together. Released a product, I was employee 9 there, released a product to market, which was an amazing experience, and got to see all of these other areas of product development and entrepreneurship, like manufacturing, operations, fulfillment, all of those things. And then we got acquired by a large power tool company from Germany called Festool. And then I took on a COO role there, managing product development and operations. And that has led me to a company called Fellow. We are a company that builds high-end, well-designed coffee gear for consumers. So we build kettles, grinders. We just released a drip brewer, which I'm going to use in my presentation. We compete with Yeti on tumblers and things like that. And you can find us anywhere from Blue Bottle to Crate and Barrel or Williams-Sonoma. We're in 70 different countries. And we have operations in China and also in Europe, and we're based in San Francisco, where I am. So, and I'm the COO there. I manage all product development and all operations. And our company is about 100 people. Okay, so now I'll just launch into it. What is good product design? So in my opinion, to create products that really resonate with users, it's essential to understand what their problems are and design solutions to solve those problems in a very, very meaningful way. So one of the core principles at Fellow is center the customer. And so this is a user-centric approach that is at the heart of making successful products. And I feel like we missed that on Google Glass. We put technology ahead of the user. And so you may, like I said, Professor Wang and I used to work for Tony Fadell, and he's famously for saying these items here: focus on real problems, understand the user's context. How are they struggling with something? You can only understand what the problems are if you're observing the user. Prioritizing simplicity and elegance. No one wants a complicated solution. And most of the best designs are figuring out how to simplify. Iterate and refining, and then really considering the whole user experience, not just what is this product, but what's the packaging like? If you have a problem, what is it like calling customer service, what's that experience like? The entire A to Z experience of the customer needs to be thought through to really, truly create a meaningful, good product. And so there are some core elements to what a product development process will look like. And this is primarily geared towards hardware, but I'll kind of share a little bit about how software kind of plays into this. So really it's about defining, developing, validating, producing, and then releasing to market. So each phase is critical. So the planning phase is all about understanding what your business case is. What is your business model going to be? How much is this thing going to cost? How many do we think we can sell? What problems are we trying to solve? And then you kind of move into the concept phase, which is not necessarily prototypes, but it could be, but it's sketches and wireframes and ideas that are coming to the surface to help you kind of validate what you thought about these problems that you've surfaced. And then from there, you move into prototyping. And this is really about building something. It could be a software prototype, could be a hardware prototype, where you're really trying to validate your product assumptions. So you think you have certain features that are really important to a customer. This is the way to test those out. It's also a way to test out maybe some key technologies that might be new to your product. And this is the phase in which you want to really de-risk those things. And then you move into engineering validation. So in the hardware world, and at least at Fellow and most of the companies I've been at, especially Apple, this is one of the most important phases. This is really where, at least in the hardware world, you're ready to start investing hundreds of thousands of dollars maybe in tooling for mass production, so that you can really understand. But at the end of the day, it's really about validating the engineering specifications that you had set out. So you start with kind of what the marketing requirements are, what the user needs are. You move towards kind of defining your feature set, and then you need an engineering specification that's going to map back to all of those product features. And that's where you kind of validate this in the engineering phase. And then you have one last chance to get it right, which is the design validation phase, where this is where you're tuning cosmetics, you're fixing all the final things to make this thing ready for prime time. And then you move into mass production. And it doesn't stop there. There's a huge phase, and probably the bane of my existence at the moment is sustaining and end of life. So you have to monitor what customers are doing with this product. Is it going well? What is failing? Nowadays, you can be so close to the customer. There's reviews, there's Reddit, you can see what customers are saying, and you need to be able to kind of address and move quickly. In hardware, it's a little bit more challenging. In software, you can get analytics, you can rapidly change things. So in the software world, it's maybe less linear, but it's still this design, build, test cycle over and over and over again. And you may not be investing hundreds of thousands of dollars into tooling for mass production, but you're going to be investing a lot of money into software development and scalability of your solution. So this is the last slide I have without examples. I just want to give you a little bit of a foundation. So here are some key roles and responsibilities that I'd like you to understand. So number one is a product manager. And you probably have heard these and maybe are pursuing some of these roles. But really a product manager, a good product manager, is somebody who sits between engineering and the business. So you have business needs and you have engineering. And this person sits in the middle, helping define what the vision and the strategy of this product should be, prioritizing specific key features, and then managing the product lifecycle as it goes through that process that I just showed you. That's different from UX designers, or even industrial designers maybe for hardware. So UX designers are, and UX is for user experience. It's really about designing intuitive and user-friendly products that meet these users' needs. And they're distinct. These two things are distinct. Sometimes in small companies, they can be the same, but sometimes, most of the time, they're not. You have somebody defining what the product should be and almost acting as like the advocate for the user, almost like a mini CEO of the product. And then you have the designers who are trying to meet those product needs. And same thing for engineering. Engineering is building and maintaining the technical infrastructure for the product. And this is the delicate balance and the dance that's really important to making good products, because you could be a product manager and you could say like, oh, I want this product to do a million different things, but you may not be able to do that and engineer it at a cost or a reliability that's reasonable. And so this is where the balance and the debates happen early on. And then lastly, product marketing manager. So this is understanding the market and the customer and crafting a story to be able to go and tell this outwardly. So you can think about the product manager kind of being an inwardly focused, focusing on the product, and then the product marketing manager saying, how am I going to tell this story to the outside world? So this is the framework that I want to go through, and it's the why, the what, and the how. So the why, the marketing requirements. This is where the product marketing manager potentially would be, heavily involved. And a lot of times you'll hear a term, the MRD, the marketing requirements document. And this is really, not thinking about what the product is yet, not thinking about how we're going to build this, but like what problem are we trying to solve? So first thing that's in a marketing requirement is target, market, and opportunity. And I know you guys are going to go through this in the class, this semester. So really what wants to be in here is a detailed description of the intended user, the customer base. Who is your customer? Who are you going and targeting? And what's the size of the prize? Is this a really small niche market, or is this a very large market? You'll probably be learning about TAM, total addressable market, service addressable market, et cetera. Then problem statement and vision. So a clear articulation of the problem that the product aims to solve. And what unique value does it give to the customer? Competitive analysis. You want to know what your competitors are doing. You want to know who's building what at what price, what features do they have, and understand why your product is different than that. Product positioning. How are you going to talk about this product on the market? Okay. And then pricing and distribution strategy. You want to know how much you're going to sell this for, at what margins that make it successful for you. And then you want to know how you're going to get this product to a customer. If it's hardware, are you going to sell it on your website? Are you going to do a Kickstarter? Are you going to try to partner with a retailer? In the case of Fellow, we were really lucky. Our founder from the very beginning was a hustler, and he found a way to get into Crate and Barrel, and they took a bet on him. And we've been omni-channel since the very beginning, and it served us incredibly well. Because a lot of direct-to-consumer brands right now are really struggling. And so when our direct-to-consumer business is going down, our wholesale business is going up, or our Amazon business is going up. And so being omni-channel is very challenging, but has been really, really helpful for us. And then what's your go-to-market plan? How are you going to promo this thing? What are your sales strategies? A lot of times I've been in meetings where we're pontificating on a product, and it's like someone takes 60 minutes to articulate what the hell this thing is supposed to do. It should be 3 simple bullet points. And it may take months to get there. But for us, target market. Who was the target market for us? The coffee enthusiast, because our brand stands for really high-end coffee. We're not bottom of the barrel. We're going to be at the high end. So we want to make sure that the coffee nerd respects us, and we want to build this for them. At the same time, it's a pretty niche market. If we were to say, what's the total addressable market for just the coffee nerds, it's pretty small. So we need to build for the general coffee drinker. And building, it seems simple, but building a product that does things well for both of those cohorts is very challenging, because the coffee nerd wants something that's, I can tune all these parameters, and I can go really, really deep, and I can customize this. The general coffee drinker just wants to press a button. And so where do we fall in that spectrum? But that's where we started. What's the problem statement? We have found specialty brewing methods, like pour over, tend to be less inconvenient. They take more time. Speed, volume. You have friends over, it's going to take you a while to do 10 cups of pour over. Coffee brewers on the market are typically hideous. They look horrible. And I think this goes, not just within coffee, but into a lot of the appliance space. There's a lot of room there for well-designed products. And then lastly, drip coffee makers have a reputation for just making poor quality coffee. It's really about convenience and cost. What would be really helpful for you as you're developing like your products and your pitch is like when you look at the competitive analysis, it's not just showing a bunch of products, it's breaking it down. What features do they have? Where are they sold? What are the reviews? Where do they fall short? I almost like to, see a table of this that says like, hey, here's what's on the market and here's where they fall short, or here's the bar that we need to hit. And then our go-to-market plan, I recognize we're a little bit more established. We've been around for 10 or 12 years and we have fairly large distribution now, but direct to consumer, so DTC as we call it. And we wanted to start with the pre-sale because we wanted to drum up, a bunch of interest. We wanted to launch in Amazon, which is about 25% of our business. And we wanted to launch in wholesale because that's a huge part of our business. And we want people to be able to, we want to meet the customer where they're at. And if they're shopping at Crate and Barrel, we want to be at Crate and Barrel. And so we wanted to pick an exclusive launch partner, which was Crate and Barrel. And so that was kind of how this all came together. And you can see here, there's nothing about a specific feature, or there's nothing here about a technical spec, like a heater that you're trying to use. This is like just talking about what you're trying to solve and what value you're going to bring to the user. So the second is really about the what, the product that you're trying to build. So in this framework, we're talking about what's the purpose and objectives. There's some overlap with the why, but a clear statement of this intended use and what it aims to achieve. And then here's where we get into features and functionality. So a detailed description of the product's features, how they work and how they benefit the user. So you have these value propositions of like what you want to do. We wanted to make pour over quality coffee, but now we need to start talking about what are specific features that get us there, which I'll go into in a second. User interface and experience. This is where we start ideating around visual designs and layouts and user interactions. This is also where we start playing around with industrial design. Being at Apple, I have a high respect for industrial design, and pretty much every company I've been at, that this design process is really, the amazing, magical part of the development process. And then performance requirements. What's the expected life of this product and how is it going to work, and how scalable is it? This may not be, this isn't technical specs, but in the software world, okay, this needs to be able to scale to 1 million users or 2 million users, or there's certain, basic requirements that you want to call out here. And then any constraints and assumptions, and then release criteria. What is good enough to, what are you going to use to determine that this product is ready to release? All of these things, especially in the software world, you'll hear MVP, MVP, MVP. This is where you're stripping out everything that is not essential to find out what's your minimum viable product to release to market. And that's why the last part, release criteria, is so important because you need to understand what is good enough for me to launch, and then what can I change after launch. In the hardware world, it's a little bit more challenging because making changes involve a lot of money and time. So the MVP needs to be somewhat scalable. So in the case of the brewer, here's an example of some of the features that we cared about. So we wanted something that could go from 1 to 10 cups batch range. Temperature control, we stand for precision. We wanted to be able to go to the degree temperature control, which most brewers on the market can't, from 80C to 99C. Again, this is not talking about the technology that's going to be used to achieve this. This is just the feature that we care about. Filter compatibility. We found that as we were doing research, not many brewers on the market can do a single cup pour over because they don't, for a variety of dorky coffee reasons that I won't bore you with, which, by the way, I've learned more about coffee in the past 2.5 years than I ever thought I would. But most brewers on the market, you have to make a full batch. And if you do 1 or 2 cups, you're going to get horrible, horrible bitter coffee. And so we felt, hey, we want to make a machine that if you want to do a pour over, just like you would at home, we want to mimic that quality. But we also want to do it at the batch level. We have, kind of high level specs for our carafe performance. Again, that's not how we're going to achieve it. And then notable features. We want a removable water tank. We want configurable temperature. We also make tumblers called Carter. And so we wanted this to be Carter compatible. We wanted to be able to take that carafe out and put a nice cup or a ceramic cup or a mug in there and be able to brew directly into it. We wanted to do dynamic ratio add. We wanted to be able to change. A lot of making good coffee is about changing the ratio of water to coffee. So we wanted to be able to allow the user, remember I talked about we want to be able to be there for the general coffee consumer who just presses a button, but we also want to give a bunch of levers for the coffee nerd. So that's where we can get into dynamic ratio add and brew countdown, and then we probably went overboard on the app control and OTA, over the air updates. But again, this is not really diving into any technical specifications. The how. So how to properly assess and implement your product ideas. So the how is about, this is really where we do get into, the engineering and technical specs of the product. So we had the marketing requirements, now we have the product requirements. Now these are really where you get your engineering requirements. How are we going to achieve this? I'm explaining this fairly linearly, and I don't want it to be like this is exactly how it has to go, but generally this is how it flows. And of course, as you go through development, you're going to realize, crap, I can't do this because of this new information that I have, or this too difficult technically, or it's going to take another 6 months. And that's where you have a nice debate, and the product manager steps in and says, okay, what are the pros and the cons of pulling this feature? But I want to kind of give you the framework. So technical specs, descriptions of how the product, hardware, software, and other technical components and what they are. Design specifications, detailed drawings, diagrams, 3D modeling, maybe even kind of high-level software diagrams for or algorithms. Interface specifications. This is going a little bit more deeper on basically how we want each subsystem to work together. And then detailed performance specs. So what are the metrics, targets for product performance? Testing and validation. This is a huge part of the product development process. So what's the criteria to test this thing? Under what conditions is a user going to use this thing? How reliable is it going to be? I have so many examples of us developing products that we didn't really think through how the user is going to use this thing. And then we found in production, a lot of these products were breaking. And we then have to take that feedback into the next, design cycle. A good example for us is, everything needs to be dishwasher safe. And everything needs to also be food safe. And so we have a bunch of coatings on our products, and we need to make sure that those meet all the requirements and reliability. I'll go into a kind of horror story working at Apple a little bit later about how we were failing a validation requirement, and I spent 3 months in China trying to fix it. And then regulatory and compliance requirements. This is mostly on the hardware side, but there are some compliance requirements for software as well, like GDPR. If you're going to have servers in Europe, you need to, and you're going to be taking users' data, you need to have this clearly defined. So these are the standards and regulations that a product must meet, such as safety or environmental. So here's some examples, again, going with the brewer. This was our high-level UI overview. We have a color screen, we have a settings knob, and we have a brew button. And as we were going through the process, we realized that users are super confused with these two buttons. Might seem really trivial, but this was our assumption, and then we kind of went into user testing and found that this is really complicated, so we ended up stripping that out. But here's detailed UI about how do we want this thing to actually work. These are kind of early prototypes, but we had a sleep screen. We wanted a very, very clean menu screen that people could go into and dive as deep as they want. And then we wanted clear feedback to the user. Here are some examples of some technical specifications. So on the left-hand side is like an electrical engineering block diagram. So this is like the nitty-gritty of how the system's all going to work together. And then a product design block diagram. So we have drip stops and thermal sensors and detailed components. On the top right, this is a new technology, a new component that we worked with a company to develop to get to the degree temperature control instantaneously, which no other brewer on the market has. So this is kind of an example of how the technology that was required or used to meet those product requirements. Validating your assumptions with prototypes. So each phase, whether it's the concept phase or the prototype phase, whatever it might be, you need to build something to prove to yourself that you're on the right track. So in the kind of product requirements phase, you might need to build foam models or a quick wireframe or something like that to prove to yourself, like, okay, I'm on the right track. This feature seems pretty cool. In the later phases, you may need to build more detailed prototypes to validate the technology. So some types of some examples of these prototypes are looks like prototypes. So something that's maybe non-functional but just looks exactly like you want it, so you can understand how you're going to interact with this product. UI UX protos, kind of what I shared right before this. Ergonomics prototypes. How is somebody going to physically interact with this? Is it too big? Is it too small? Apple has a whole group called Human Factors that just does this within the design team. Architecture prototypes for your technology. And then finally, a works like and looks like prototype. This is something that is ready to go that, before the big phase of investing in tooling. And so some examples here. On the right-hand side, we have a couple quick foam models where we were looking at different sizing of our Aiden brewer. There's so many things that needed to go into it. And you can see they're like 10 millimeter differences, but like that's the level that we really cared about, making sure this thing felt really compact and really magical. And sometimes you can only do that with a physical prototype. On the bottom are some kind of more detailed technology prototypes of when I was working on Shaper Origin, which I said was a handheld CNC machine. So this is kind of somewhat of an ergonomic prototype, but also a functional prototype to ensure that we had the right technology to meet the user requirements. This is a very early kind of prototype, one of the first prototypes of us defining what our UI is going to look like on a brewer. So we did it off board because we couldn't get the electronics to work, but we did it in a program called Origami. And we were able to kind of go through that entire workflow and just prototype it for the first time and see what this would look like. There are so many tools out there to be able to prototype that you don't need to spend a bunch of money. You can do this on kind of a quick software platform to be able to prove these things out. During this phase, it's really important that your product fits into your business model. Like I said, this thing, unless you're a nonprofit, ideally you want this thing to make money so you can invest in new products. And so I'm going to define a couple different terms, which you may have heard already, and kind of talk about why it matters. So the first thing is net sales. What can you sell this product for after giving discounts? Anytime you go to a website and you see a banner that says 10% off if you sign up, this is a way to acquire a customer. And so really your net sales are kind of your total revenue minus those discounts. The product cost of goods sold. So how much does it cost to make this product? In the hardware world, this is the actual material of the parts, the assembly, the shipping to your distribution centers, et cetera. In our case, we build a lot of products in Asia. We build most of our products in China and Taiwan, and we work with outside contract manufacturers to build our products. In fact, I was there just 2 weeks ago in China and Japan. So we have to pay these contract manufacturers. We also have to get that product out of China and to our distribution centers. We have 3 distribution centers, one in the US, one in the Netherlands to serve the European market, and then one in Hong Kong to serve Asia Pacific. All of that costs money and needs to be considered as part of your overview. There's also other costs of goods sold. There's merchant fees. When you sell this thing online, there's credit card fees. Amazon takes a bunch of fees. There's shipping to the customer. And then there's warranty that you have to take into account. Not every single product is going to perform, the 1-year warranty or the 3-year warranty. So you have to take that into consideration. And so when you look at your net sales and you take all of those costs, the difference is your gross profit. This is how much you're taking home. And then lastly, there's contribution margin, which is your gross profit minus the ad spend that you're going to use to go acquire a customer. And this is the amount of money that you can reinvest back into your business. Now, I didn't show it here, but you also have operating expenditures. You have your team. You may be, also having a bunch of contractors, or you might be rent for your facilities. Those also need to be taken into account as you look at your whole business profitability. But this is just your kind of unit profitability, which I think is really important. So you can see here, I mean, this is just a made up example, but product COGS of $50, and we're selling this for $150. So typically, we're at the 4x, 3 to 4x what our product COGS are, because that shows you where all of this margin needs to go to reinvest into your business. So it's not like you make this for 50 and sell it for 60 and you're going to make money. You're going to lose a lot of money. I want to give some examples of how going from prototyping to production, there's a lot of different things that can go wrong. So building one of something is totally different than 1,000, which is totally different than 100,000. And I think it's really important to consider some of these constraints early on in the design process. And this is not just for hardware, it's for software too. I mean, like, if you're really trying to build a scalable solution that can reach, millions of users, that really needs to be taken into consideration early in the design phase. We call it design for X. So design for quality, design for manufacturing, design for reliability. Professor Wang talked about sustainability. You may have design for sustainability early on. These are really important things to consider at the early onset of the product design process. Even within manufacturing, there's supply chain, sourcing, tolerances, etc. This is a picture of the production line about 2 weeks ago building these Aiden brewers at full max capacity. We have like 90 people on the production line that are cranking these things out 24 hours a day. So I want to give an example of designing for manufacturing. So tolerances matter. So this is the Apple remote that I worked on. It's one single piece of aluminum that's basically machined from the outside to hollow it out. It's kind of a ship in a bottle, and everything's assembled from the outside, just kind of snakes in there. And then all the parts are snapped on the outside. So when you look at this thing, there's no seams, there's no nothing. So a lot of people are like, oh, how did they build this? And this was one of the coolest products I think I've worked on. Later into production, so during the early phases of the development, we didn't really see any issues with kind of reliability or any problems. But we weren't using mass production methodologies. We were just using maybe 3D printed or CNC parts. As we went further in the development process, and I say we, but I was the only person working on this product, I didn't take into account that the tolerances, the manufacturer can't make the dimensions perfectly. We built, I don't know, tens of millions of these units, or more, I think, maybe close to 100 million. And so later into the development cycle, as we were doing some testing, we had a spec for drop testing. So we would drop these products from 3 meters, kind of to mimic what it would be like if this fell off of your table or something like that. And the buttons were just popping right off. And I was terrified because I was a young engineer, and I was like, oh my goodness, this is going to be like the first Apple product that gets released that like everyone's laughing at because it's falling apart. And I was so stressed out. And what I didn't take into consideration is that the opening here in this aluminum part will change. It'll get bigger and smaller every single unit. And this plastic part will get bigger and smaller. Seems pretty obvious now, but the design that we had come up with wasn't as tolerant to those manufacturing variations. And so I spent close to 3 months in China trying to fix this problem and try different design solutions and do a bunch of experiments for what tolerances would work. And finally we came up with a design that had some special undercuts in there and was able to solve the problem. Also, we had the same problem on this battery door here. And I remember being in China when when Steve Jobs had announced this new product along with the new iMac. And I was sitting there sorting these battery doors on the production line. And so that just came from my inexperience and my inexperience in working cross-functionally with other people to say, hey, can you look at this design? Can you show me where it's going to fail? Can you help me out? And this sticks with me that, yeah, I can build a prototype of this thing and it's awesome, but when we're scaling to millions of units, it's a totally different ballgame. This is another example, designing for quality. So this is the handheld CNC machine that I worked on, that I mentioned at Shaper Tools. And we had been in production for, I don't know, close to a year. And then all of a sudden at the production line, we heard from our manufacturer that these displays were just falling out of the units. We're like, what is going on? And this launched a couple-week exploration and root cause analysis to figure out what's going on. We had never seen this in production or in development. And as we started looking into it, this is a nice flat piece of glass that has double stick tape to a plastic piece. And as you put it into this unit and you screw it in, this whole thing kind of warps and moves. Also, we found out that the plastic was not flat. We didn't control the flatness of this plastic. So when you adhere these two things together and it wants to just pop right off. Okay, but why didn't we see that for the past year? As we dug into it and did a bunch of different analyses, we found out that our supplier, we have a supplier that makes the display. They have a supplier that makes the cover glass. They have a supplier that makes the tape. And that supplier had changed the tape to save 2 cents. Some of these things are really hard to kind of foresee, but they can be controlled in different ways. And there's some various methods called like a DFMEA, which is you try to identify where are the things, what are the things that could fail or go wrong in your product? How likely are those things to go wrong? And then what's the severity if they go wrong? Like in this case, it has a power tool sitting right on top of it. If this thing falls apart because a screw doesn't get torqued down, that's very severe. That's a safety issue. That's a full recall. That's like tank your company. So that would be very severe. And then you rank all of these things and say, okay, well, how likely is it to happen? How severe is it if it does happen? And then what are the mitigations that I can put into place to ensure that this doesn't happen? And I will say there are a number of examples out there of, and by the way, we did have a small recall on this product, not because of this issue, but luckily we had thought through how we're going to trace these products. We were able to limit it only to about 100 units that we had to fix. But these things will tank a company very quickly, even an established company. They will be so costly that they will put you out of business. So it's really important, especially in hardware, to kind of take these into consideration early on in the process. There's a whole masterclass on just go-to-market here, but like I talked about in the very beginning for the why phase, where do you want to distribute this? Is it business to business? Is it business to consumer? And then what are the channels that you want to sell in? Are there any key partnerships that you need to distribute this, whether it be a retailer or maybe another brand? What's your marketing plan and product positioning? And then what's going to be your ad strategy? Especially on the software side, it's pretty crowded out there. How are you going to kind of optimize your SEO to get people to your site? How are you going to get an online presence? And then what's going to be your ad strategy? What keywords are you going to target? How are you going to do customer segmentation? Are you going to have ads on TikTok, Google, Meta? And there's so many tools out there to be able to do that and evaluate how effective those strategies are. And then that leads into something called ROAS, return on ad spend, which you want to track religiously. And this is an example of one of the things in the earlier days of Fellow where we actually developed this product and we put it on Kickstarter. We were able to, for the first kind of two big products, our kettle and our grinder, we were able to do this pretty successfully on Kickstarter. And as you can see, we raised a couple $1,000,000. I think this is not final. I think we raised maybe close to $4 million. But that's $4 million that we can go and invest in our in our product. Now we're a much bigger company and we don't do Kickstarters anymore. But this is a great way as a hardware company to kind of gauge demand, but also raise a little bit of funds to kind of get you going. How many people have bought something on Kickstarter? I'm just curious. Really? Wow. Are people familiar with Kickstarter? Okay. But it's basically a crowdfunding platform, and there's many crowdfunding platforms out there where you can do a pre-sale on your own site. That's what we do now. Sometimes we'll put the product out there, and we'll start taking sales earlier on in the development cycle. We'll gauge demand that way. We'll raise some money, etc. Cool. All right.